Simon, and welcome to my crib. Oh, I'm dizzy. And welcome to another lesson of biology. Let's start off with this warm-up. So look at these organism photographs, and I want you to tell me, if you were a scientist and you were tasked with separating these organisms into different groups based off of shared characteristics, how would you do that? Right, so some people might have said, I would group the sea animals together. I would group bugs as a separate group, and I would group plant-looking things as a separate group, right? But I wouldn't say a million, but there's probably a dozen different ways to group all of these organisms, and every one of my students would probably have said something different. And that's a kind of a hint as to what we're going to start talking about this unit. So welcome to Unit 5. This is lesson number 1 of it. We are talking about taxonomy. And of course, this is Miss Simon's biology class. So today's lesson objective is that you should be able to define taxonomy and recognize the importance of a standard taxonomic system. You should also be able to understand binomial nomenclature and know that genus and species make up the scientific name. So, what do you call this? So there's different names for it, right? Some people say roly-poly. Some people say pill bug. And yet there are still others that call it the armadillidae. Did not pronounce that correctly, but that's fine. So this little organism has so many common names, so names that you would commonly use to refer to it. Pill bugs, roly-poly, slaters, potato bugs, and doodle bugs. Okay. However, its name is truly Armadillium vulgare, okay, which is the common pill bug. And this is just all the common names in English. Think about the thousands of languages that are spoken around the world. Okay, there are even more names for this exact same organism in other languages. So basically, there are so many names and nicknames for creatures that if we didn't have some sort of standard scientific naming system, that there's no way we'd be able to communicate clearly between cultures or even between people sitting in a classroom. So think about it. How frustrating would it be if every time you went to go buy something, the store was extremely disorganized and you had to struggle to find what you needed? Imagine trying to find what you need in a store that is so disorganized. Okay, so in the way that you like your life to be organized, biologists like to organize their studies. Okay, when they organize their studies, they find out that it's easier to communicate and it's easier to retain and share information when organisms are organized into neat groups. Okay, this is known as biological, so living things, classification. Okay, so that's why we know certain things as plants. It's called kingdom Plantae. We know fungi, that's kingdom fungi. Animals, kingdom Animalia. Then yet, you guys probably don't know these, but there's Protista, and then there are bacteria. Okay, so classification is going to be that grouping of organisms that are based on their shared characteristics. So for example, there's these things called primates, okay, and we have great apes. They have shared characteristics that look like this, and then hominids or humans, we have shared characteristics where we have feet and hands that look like this, right? So so we humans all have a shared characteristic, so we are put in a group, while great apes have separate shared characteristics, and they are put in a separate group. That is called classification. Classification is grouping of organisms based on characteristics that they share. Okay, so classification is not just in terms of science. In school, you're classified by grade level. Some of you who are watching this are freshmen. Some of you who are watching this are classified as sophomores. Yet, I think I have 1 or 2 juniors in this class. And then eventually you guys will be seniors in this class. Right? So at school, you are classified by grade level. Freshmen all share the same characteristics that they have, I think, 8 or less credits in high school. Sophomores are classified as people who have some more credits, and then seniors are classified as people who are about to graduate high school. So you have shared characteristics. Okay? So the study of taxonomy is, again, that classification of organisms in what's known as a hierarchical system. So a hierarchical system just means that there's levels, right? There's levels to it. That's all that means. A hierarchy is levels. Okay. And again, we classify organisms based on their shared characteristics. So, what do they share? Okay, so taxonomy is how scientists organize all the organisms on Earth. So there are all these different levels. Okay, this is the hierarchy. And we go all the way from very specific at the species level to very general at the kingdom, or even there's even another one called the domain. Okay, and the reason why taxonomy is so important is because, again, it makes it easier to study living organisms, locate information about them, identify relationships, and communicate our findings with other scientists, even if they're in other countries. So, again, think back to that. Well, I'm ahead of myself. So, in the real world, when have you used a classification system? So if you didn't realize it, well, grocery stores. Grocery stores are grocery stores classify food to make it easier for customers to find items, right? So over here, everything that is a fresh produce is going to be over here. Everything that is bakery, so breads and cakes and cookies are going to be over there. And yet we know that there's an electronics department, so things that are electronic, they have a shared characteristic that they use electricity. They're in one section, and then we have clothing items. They have a shared characteristic that they are designed to be worn on the body. Okay, so that's classification. Yet another way that you use classification every single day, whether you know it or not, is where you live. So post offices are going to sort mail according to the state, the city, the zip code, the street, and the house number, right? Post offices are going to are going to use your classification, so your locations, your identifiers, in order to send you letters in the mail or packages from Amazon. Okay, so there are literally like 7 million or more species on planet Earth. We've identified only about 1.5 million. So there are so many species out there that we have no idea about. So, fun fact, we've identified more than 35,000 species of spiders, 440 species of sharks, and 10,000 species of birds. So, yeah. But we know that there are millions and millions of species that we have not identified. Especially if you think about like deep down in the ocean, all of that stuff, like they're there. Okay, so what is the point of this? What's the point of taxonomy? Why are we even learning about this? Well, again, for the third time, taxonomy sets up an organized system for scientists to name and categorize organisms so that everyone across the world knows exactly what organism is being discussed. So instead of you looking up roly poly and getting a couple results, you can look up armadillidae and find all of the results, right? Because there are common names, but then there's also going to be that scientific name that everyone, regardless of what language you speak, you're going to know it. Okay, so how exactly do scientists come up with a scientific name for each organism, right? How do they go from looking at a roly poly and say that's Armadilliae vulgare? How'd they do that? Well, let's find out. So there's this dude. His name's Linnaeus or Linnaeus. I don't really know how to pronounce it. I don't speak Swedish. But he was a Swedish dude. He lived in about the 1700s. And essentially what he did is he went out and he looked at a bunch of birds and then he was like, this bird is different from that one. It's different from this one. But these two over here are very similar because they have the same feeding habits. These are both predator birds. And then this one over here is just a cute little flutter bird. And so I'm going to group it in a separate group, right? So we just looked at a bunch of birds and started grouping them based off of how they behave and where they lived. And then the field of taxonomy was born. Side note, it must have been cool to live like back in the day because you could literally discover anything by just looking outside and being like, wow, have you ever thought about that? And then people are like, no, actually, you're kind of a genius. Now everything's discovered and made, so kind of sucks. Late stage capitalism. All right, the modern taxonomic system. So I know you guys are tired of levels of organizations, but we've got to do them. They're just the way that we communicate in science. Okay, so we have what's called a domain. A domain is there are three domains of life. We'll talk about them later. Okay, you just need to know that there are things called a domain. Domain is just a huge group of organisms on Earth. Then we get smaller and smaller and smaller as we get more and more specific. Notice that I'm saying specific, species specific, okay? Species specific. Say it with me. Species are the most specific level of the hierarchy. Okay? Domains are going to be huge, and species are going to be really small and specific. Okay? Specific species. All right, I'm going to be a little bit annoying, and I'm going to play this taxonomy song because I kind of like it, and I feel like it's really helpful and explains this a lot better than I've been explaining it so far. So let's watch it together.
Sashie their habitat and their type of babies. So the span in the edge wanted to organize the fan things. So we made a system we call a taxonomy. So every living thing is sorted in 7 major levels, seven, and at the top, starting right, specific at the bottom, the domain, right is rank, it stops with the kingdom, and phylum, class, order, and the genus and the species, kingdom, and phylum, class, order, and the genus and the species. Let's take a last action. The kingdom in a million. The phylum is called data. In class, mammal, in order, carnivore. In family, unity. Genus is the genus. In species, mammal, genus, lupus. Genus, lupus. Okay, here we go. Scientists, names and kingdoms. Pantanimal, bacteria, protists, fungi, archaea. And then the phylum divided into 30 phyla. More similar characteristics have in common. Then phyla broken down to classes. Then orders, even smaller branches. Then families next, more common. Genus, very close to the end. Specific, non-species. Humans almost sapient. Kingdoms and phylum, class, order, and the genus and the species. Kingdom and phylum, class, order, and the genus and the species. Let's take a last action. The kingdom in a million. The phylum is called data. In class, mammal, in order, carnivore. In family, unity. Genus is the genus. In species, mammal, genus, lupus.
Yeah, so that's the scientific classification song. Pretty cool, right? It basically explained everything that I was trying to explain, but better and catchy and in a song form. Isn't that awesome? Okay, I don't want to click it again. Next slide, please. Please. Okay, so like the video said, and like I've been trying to explain, the levels of classification are going to fit inside of each other. So do you guys know what these are? These are these little Russian nesting dolls. So essentially what happens is that, say you have a doll, you open it up, and there's a smaller one in it. Then you open up the smaller one, and there's a smaller and smaller and smaller and smaller, right? They all fit inside of each other, right? They're Russian nesting dolls. Well, the levels of classification are the exact same way. They're the exact same way. So we have domains, and then kingdoms, and then phylums, and then class, order, family, genus, and then species. This is the very smallest, is species. So if two organisms belong to the same phylum, they must belong to the same kingdom. If two organisms belong to the same kingdom, they must belong to the same domain because, again, they fit inside of each other. They fit inside of each other. Okay? So this is another representation of the modern taxonomic system. So again, at the very top, this graphic does a very good job of showing you that the levels, they get more and more specific, smaller as you go down. So the domain is the biggest, the kingdom, then the phylum, then the class, then the order, then the family, then the genus, and then the species. Okay, and these little like parts underneath are actually the classification for vulpes vulpes, which is, I think it's, yeah, the red fox. So pretty cool. Okay. So again, this is another representation of it. Notice that again, up here at the top, the very general, the very broad, the very inclusive are going to look very big. And then as you get smaller and smaller and smaller and smaller and smaller, more specific, specific species, please, no one should get that wrong. Like, please don't ever get that wrong. Okay, very specific is going to contain organisms that are very closely related in terms of evolution. While up here in a kingdom, inside of an entire kingdom, there's thousands of organisms, and they're not very, very related. They're a little bit related, but they're not very, very related. And as you go down and down and down, they're getting more and more related until the species, they are very related organisms. Okay, so let's look right here. These two levels down here are very interesting. Okay, they're very interesting. That's why I circled them. So the genus is going to be the organism's first name. Notice I put that in quotes. It's not really called the organism's first name, but it's a great way of remembering it. Okay, so it's the organism's first name, while the species is going to be the organism's last name. Okay, so kind of vague. Let's look at some examples. Okay, let's look at some examples together. That was kind of vague. So humans' scientific name is Homo sapiens. So Homo sapiens is humans. So we're talking about the genus. That's the first part, the first name. That is going to be, so if the word is Homo, or the name of humans is Homo sapiens, that's two words. Homo sapiens. Then Homo is that first word. That's going to be the first name. That represents the organism's genus. Okay, you still with me? Now, there is what's called the species name. That is the second part of the scientific name. So out of Homo sapiens, the second part is sapiens. That represents the species. So genus and species. Okay? Another thing about species is that they are the smallest, most specific group in taxonomy, so they are the most closest related. Species can successfully mate and reproduce, so this is bringing it back to what we learned before, where you're talking about speciation. So speciation is basically when organisms can no longer mate with each other. There's had to be two separate species. So as long as, if organisms can mate together and produce fertile, viable offspring, then they are the same species. If they cannot successfully mate and produce fertile, viable offspring, then they are different species. Okay. So, scientific naming is this thing called binomial nomenclature. Bi, like bicycle. Two. Nomen is Latin for names. So, binomial nomenclature just means two names. Canis familiaris, Homo sapiens, Armadillo vulgare, right? So there are, so again, two-word names for organisms. That first word is going to be the genus. That second word is going to be the species. Okay, and one thing to note, why they're like Canis familiaris and vulpes vulpes and Homo sapiens. I'm sounding Italian. I meant to sound Latin. I'm sorry. They're written in Latin because, come on, give it to them. Okay, I lied. That's later. I am, okay, hold on. I'm sorry. I seem like a mess right now. I'm really trying my best. I am. So, understanding binomial nomenclature, let's just play around with that a little bit more, and then I will reveal to you why they're written in Latin. So, understanding binomial nomenclature. So, this is a puppy. So cute. Yay. So, the name for a dog is Canis familiaris. So, Canis is the genus, familiaris is the species. And how do I know that? Well, because in the scientific name, the genus always is first and the species always is second. It's easy. And it also matches up with the order of the levels of organization or with the levels of classification, right? Because it goes family, genus, species. Genus, species. Okay, so again, why do taxonomists use Latin? Well, not again, but I'm going to actually tell you now. So, Latin is a dead language. So, that means that no country or people currently speak it. So, it never changes anymore. Okay? Unlike in America, we start getting, or in English speaking countries, we start making up words like slam dunk and all kind of stuff. Like, so yeah. Latin is a dead language. No one country or people speak it, so it never changes anymore, which means that Latin is the same that it was in the 80s, is the same that it is in 2020, 40 years later. Okay, so it's understood by scholars around the world. So scientists that are in Mexico can communicate with scientists in Afghanistan, that can communicate with scientists in Uzbekistan, that can communicate with scientists in Honduras, that can communicate with scientists in Vietnam. Okay, scholars around the world all can use Latin because, again, like I said, it's a dead language, and that's why it makes it so good for science. It also sounds really cool, like Canis Familiaris. It sounds like you're casting a spell or something. So let's explore the many levels of classification. So we're starting down here with the domain. This domain is called eukarya. So look at the organisms whenever this little bar goes away. I hate that it pops up. Look at the organisms and you notice that they're very different, right? We see a bird, I see a tree, I see a whale, I see a worm, and even some bacteria. It's a very big, not a bacteria, maybe a bacteria, I don't know. It's very big. Then we're going to go to the next level, which is kingdom. So this kingdom that's being shown here is Animalia. And as we notice, we still see lots of diversity, lots of organisms, but it's getting a bit more specific as compared to the domain. Then we see Chordata. Okay, we're seeing less diversity. It's getting smaller and smaller as we go up to class and order and family. By the time we get to order and family, these are just like birds, right? And then genus Cardinalis, we see two types, and then we see Cardinalis cardinalis is the species, which is the cardinal. Okay, notice this arrow right here. This is more specific. So as we are leaving domain and we're going lower and lower and lower on the chain, then we are seeing we're getting more and more specific. So one thing to also notice is that this same organism is in all of them. Okay? The same organism is in all of them because this is the species that we are looking at. I feel like I'm not doing a good job. Honestly, I'm gonna keep it, but I might redo this video. Okay, here's yet another representation of it. This time we're looking at plants. So up here at the kingdom level, it's very broad, it's very big, it's very large. And then we're getting smaller and smaller and smaller, more and more specific until we reach a single species. Yet another representation of this. Kingdom, phylum, class, order, family, genus, species. Okay. Unfortunately, we must memorize the levels in order, but it's not that hard. Like, it's really not that hard. We're gonna go to it. So this thing called a mnemonic. Have you ever used a mnemonic? Wow. So this thing called the order of operations, PEMDAS. You probably know PEMDAS, whatever you call it. In math, parentheses, exponents, multiplication or division, addition, subtraction from left to right. Oh, one thing to note, guys, listen, I don't know why so many people my age don't understand this, but PEMDAS does not mean parentheses, exponents, multiplication, then division. It means multiplication and division in order, starting from the left, and you go over to the right, the way that you read the problem. It doesn't mean do all multiplication first and then all division. No, you do in order. Multiplication first, and then you go into division. Okay, that's a life skill that a lot of people, for some reason, didn't get. So I want to make sure that y'all get that. Okay, if you did not know that, that is what it is. Okay, Okay, same thing with addition and subtraction in order as you read the problem. Sorry, I got really passionate about that. Like I said, people my age, I'm like, y'all are grown and y'all are not do not know the order of operations. How are you living? How are you surviving? I don't know. Another mnemonic you probably have heard of in art class, Roy G. Biv. So it teaches you how to know the rainbow. That's ignore that. That's not even funny. I don't know why I put that there. So we have kingdom, the biggest, all the way down to species. So kingdom, phylum, class, order, family, genus, species. So a mnemonic I came up with, or I didn't come up with this. It's been around since the 1200s. I don't know. King, well, I couldn't count on the 1200s because taxonomy was invented in the 1700s by a Swedish dude, Linnaeus. So I would say 1800s it came around. I don't know. Kingdom, phylum, class, order, family, genus, species. So you basically make up a rhyme for remembering the order. So King Philip came over for good soup. However, I want you guys to make up your own. So this should be a free 100. The 6 weeks is ending soon, so take advantage of this. I'm trying to give y'all some free 100s. So yeah, you're just gonna make up your own. Kayla plays clarinet on the football field. I don't know. I lost it. But my freestyle warriors, this is your chance. If you make up a song, there might be some more extra credit in it for you. Just saying. That was a horrible link. I'm very embarrassed. Okay, let's keep moving. Let's wrap this up. I know y'all are tired. I'm tired as well. So, why is taxonomy important? Well, it shows evolutionary relationships. So, if two organisms share the same taxonomic group, then they are related. Obviously, two organisms that are in the same genus are related. Three organisms that are the same family are going to be related. Same order, they're related, they're related, they're related, they're related. Now, we would say they're more related if they're in the same genus, but I mean, even in the kingdoms, they're still related in some way. So, again, the more groups they share in common, the more closely related the organisms are. Okay? So, for example, I think that's a fish. Yeah, this fish and this elephant share two groups. That's a decent relationship. But this fox and this wolf, they share 1, 2, 3, 4, 5 different groups. So they're going to be more related to each other. Okay, so the more groups they share, the more closely related they are. And that makes sense, like just thinking about it. Like obviously if we have more groups in common, then yeah, we're going to be more related. Okay? So organisms are distantly related in domains, and in a species, they're going to be very closely related, and it's going to increase the relationship as we go down. So think of it like a big family reunion. So organisms are going to be distantly related in the big family reunion. So that'll be like your second cousins or great aunts and people who aren't really your family, but y'all just have known each other so long that that's your family. Okay? And then as you get closer and closer and closer into your smaller and smaller groups of your family, then organisms that are going to be very closely related are going to be like your mom, your brother, your sister, and you. Okay? So let's recap, practice, let's wrap it up. Let's get to it. We can power through last couple minutes. Okay. So here, is the dog more closely related to the elephant, or is the dog more closely related to the butterfly? So here's a hint. I'm gonna help you out here. So I went ahead and I identified the organisms for you. So we're talking about the dog. I said earlier that was a wolf, but elephant, butterfly. So is the dog more closely related to the elephant or the butterfly? What do you think? Okay, let's go to it. So we're talking about more closely related. So we're talking about who shares more taxa in common. So we're going to say the dog. The dog is more closely related to the elephant than it is to the butterfly. Okay, look. The dog and the elephant share this level, they share that level, and they share that level together. So that's 3. The butterfly and the dog only share that one taxa in common. Right? One taxa in common versus 1, 2, 3 taxa in common. So which is broader? The kingdom, for example, kingdom Plantae, or the phylum, for example, phylum Chordata? Kingdom. Kingdom is up here and phylum is down here. So kingdom is broader, less specific. Okay, which is smaller, more specific? The genus or family? Genus is going to be smaller. Genus is down here. Family is up here. So family is more broad. Genus is more specific. It's right next to species. I keep saying it like that. I'm sorry. So how many words did Linnaeus, I don't know, system use to name each organism? 2, 3, 1, or 4? Two parts, two-part names, right? So for example, the pebble crab is Xanthias lamarcki. 2 words. Xanthias is one word, lamarcki is another one. The first word is always the genus, and that second word is always the species. Always, 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 genus and then species. Okay, which 2 of these organisms are going to be the most closely related based off of this chart? Okay, the way that we solve this problem is we're going to start with the most, so we're asking for who is most closely related. Okay, so out of all of these levels of classification, species is going to show us that they're mostly related. So let's look right here. Are any of these organisms the same species? No. So none of the same species, so let's go up a level and let's see about the genus. Are any of these the same genus? Yes, these 2. So these 2 have the same genus, so they're going to be the most closest related to each other, organism 1 and organism 4. Okay, so we're talking about something that is most closely related. You want to go to the one that shows that they are the most closely related, right? The species. If they're the same species, they're going to be extremely related. Okay, but if this problem would have asked who are the least related, then I'm going to start at whatever level of classification is the biggest that they offer me. Then I would have started here if it asked me for least related. Okay, so let's just recap our lesson objective real quick to close it on out. So students should be able to define taxonomy and recognize the importance of a standard taxonomic system. So taxonomy is classifying organisms into groups based on their shared characteristics. This is important because it allows scientists to communicate internationally across language barriers and stay organized. Okay. The other lesson objective was that students should be able to understand binomial nomenclature and know that genus and species make up the scientific name. So bi is 2-part nomen naming system. So genus is the first part, species is that second part. So for example, Homo sapiens. Homo is the genus, sapiens is the species. So your next steps are going to be the virtual worksheet. So you're going to do some practice with this, an exit ticket, and then of course any makeup work because like I said, the 6 weeks is winding on down. People are playing games and that's not good. So let's do well. Go forth and do great things.